All right, we're going to get started. I want to welcome everyone to this first webinar series entitled Co-Chairs Webinar Series Responding to COVID-19 and Beyond. This is in fact, the Blockchain and Education webinar series. And this is going to be a three-part series, though there's a fourth that I'll refer to my colleague to speak to. And we're quite excited to have a very vibrant group of individuals that will be presenting more or less every week, starting today and through July. And today will be an overview of blockchain, and I'll refer to my colleagues to elucidate on what that will be about. Just a few housekeeping issues. I assume everyone can see my PowerPoint slide. I want to just give a short a few housekeeping matters and a few other things to address. But I will, of course, I want to welcome all of you. We have people coming from all over the world today. We have about 25 participants and perhaps more will come. We had about 60 that registered. As far away as Fiji in the Pacific, India, Mediterranean, Sub-Saharan Africa, Namibia, Botswana, Mauritius, South Africa, Bahamas, and of course, North America. Where I am located. I'm from the Commonwealth of Learning. My name is Kirk Paris, and I'm the Advisor Education. And I work through a range of initiatives through the Commonwealth. Mainly we focus on leveraging open and distance learning to our Commonwealth states and try to give technical advice on mechanisms to leverage that kind of system to widen access to learning. My information is there at the bottom, as is my other colleagues who I'll introduce in a moment. So just a few housekeeping issues. Of course, your mics, I've said silence your mics. Your mics are automatically silenced. The arrangement with this webinar is that the panelists will be overseeing this, and then we will be inviting you at certain points throughout the presentation to offer comments or questions. Of course, you can always raise your hand. If you see that in the chat, there's an option there, and that will enable me to perhaps call on you to pose your question and unmute your mic. Otherwise, myself and my colleague, Dr. Alex Grech, will be collating the questions and trying to field them to our presenter, Dr. Joshua Ellul, in a moment, as we go through the presentation. So there's two platforms there. There's the chat room where you can just say hello to everyone, whatever the case, you might pose a comment, but there's also the Q&A where you can pose questions. Of course, people might pose questions in the chat, but we'll be looking mainly in the Q&A portion or the tab there to address questions. I think that's about it. The session is being recorded, and we will make this available on our respective YouTube channels. As I represent the Commonwealth of Learning, my colleague, Dr. Alex Grech, represents the Commonwealth Center for Connected Learning, and then Dr. Joshua Ellul, our presenter, well, he wears a few different hats, but he's representing the University of Malta. So I'll stop there and I'll turn it over to my colleague, Dr. Alex Grech, who will be facilitating the webinar. Of course, I forgot to mention I'll be chairing, but that mainly me and Alex will be looking at addressing the questions and directing them to our presenter, Dr. Joshua Ellul. Without further ado, I'll just direct then your attention to my colleague, Dr. Alex Grech. Thank you.
Okay, hi, greetings. Thank you very much for joining us. I know some of you, there's some old friends, some new friends. I'm very pleased we're kickstarting this. Kirk and I started talking about running a webinar series on the blockchain several months ago. And I think the challenge was trying to line things up sequentially, and then COVID hit us. And all of us scrambled into our relative bunkers, wherever those are, our bunkers being this screen, I guess. And this became the norm for all of us. Blockchain is one of those intriguing subjects. And I think some of you know, I crashed into it literally by accident around about 2016, when I just happened to be in Boston doing something quite unrelated. I was trying to find a way of seeing how blended learning and online learning could, and accreditation frameworks could come together. And I had an accidental conversation with Philip Schmidt at MIT Media Lab, which led to a conversation with some people from Learning Machine who are now called Highland. And things snowballed round about 2017, we'd already fast forwarded, and my tiny country became the first nation state to roll out blockchain credentials. Things can happen very quickly sometimes if there is a combination of, I guess, energy, political will, accidents, and happy accidents, I guess. And yet, despite all of this thing, that was 2017, and we're now in 2020. And around about the beginning of this year, I was getting a lot of, in a way, flack. I wouldn't say flack. I think blockchain stopped being very sexy. That's the feeling I got from several conferences that I was attending, and blockchain congresses worldwide. And so what we want to do right now is have three layers when it comes to the blockchain. So Joshua will kickstart this, and will explain his context and where he comes from. And look at this as almost like a little crash course, foundation course. I'm aware of the fact that some of you are very well versed in blockchain and some of you aren't. So it's Joshua's challenge is going to be to meet all of that. And I think the question I have at the back of my mind is blockchain education, learning, empowering people all around the planet. Is this the right time or not the right time? Is this a technology which is going to be considered to be stillborn? Or is the greatest innovation happening right now when things have gone quiet? Okay, so I think that's the kind of seed I will put in your heads. And I think from now on, I'd like to hand over to Joshua, and we'll take it from there, guys.
Excellent. Thanks, Alex. Thanks, Kirk. So like Alex and Kirk said, this is going to serve as an introduction to blockchain. And I know that some of you are more familiar with blockchain, but it's really important that we get everyone on the same page. So as much as possible, we're going to try to keep that this discussion is at the level where everyone who is perhaps coming from a background where they're not versed in blockchain can take part in that discussion. And we're going to try by streaming a pre-recorded video, and we're going to interrupt it at certain points where we'll discuss certain issues. But the idea here is to, if there's any burning question that you have, you can type it into the chat or raise your hand, and then we'll find the ideal time to get to those questions. Can you hear the audio now? To demystify the buzzwords within the blockchain and DLT space. And the intention of this session is to provide a generic overview, a non-technical overview in regards to what the various technologies are and what they mean to you. This could also serve as an introduction for those who are technical, and we could speak later on about a more technical explanation of the technology. So this lecture is a lecture that I have given with Professor Gordon Potch a number of times, and is joint work between us. So if you think about the way that we used to use services from the very beginning of time, really, till the mid-90s, it involved going to a physical location and interacting with a teller. So you would either go to a post office and request some service, or go to the bank and interact with a teller over there to undertake a transaction. Then in the mid-90s, along came the internet revolution. And this allowed for us to use the same services that required a physical location by logging onto a computer wherever a computer is made available, whether from your office or from your home. And this provided for services such as information retrieval, purchasing of books, and internet banking, and so on and so forth, which became the internet that we know nowadays. So using the internet, you could send transactions from your bank account to another individual's bank account, which your bank would then start processing immediately. And in the mid-2000s, along came the mobile revolution. So the very same services that became e-services through the internet were now available to not only be used through your home or your office computer, or wherever you had a computer made available to yourself, but these services could now be used wherever you are just by reaching into your pocket. We could now undertake mobile payments wherever we are just by reaching and using a mobile app, or purchase goods, or whatever other service that you want to use. And in the mid-2010s to late 2010s, the blockchain came about. Well, really, the blockchain came about in 2009, but it became hyped up in the mid to late 2010s. And it's being touted that this is going to change everything, that this is the blockchain revolution. And if we look back to how the internet and how the mobile internet, mobile services change the way that we interact services, it's very easy for a user to understand what it meant to them. Now that we're onto the blockchain revolution, it's not blatantly obvious what it's going to make a difference for the users of the services. So how does blockchain change the way that we will interact with services? Well, it's not going to change. And if it's not changing the way we interact with services, then what is changing? And what is going to change is all about the issues associated with trust, the issues associated with trust of service providers. If we look at how services are used nowadays, here we have Amazon. And let's say that we trust Amazon as distributors. You're a book distributor, and you send your books to Amazon. And you trust that Amazon will sell your books for you. And you trust that when someone sends payment for your book, they will send you that payment. And if you're a user of Amazon, you trust that when you send payment to Amazon, that they will send you the particular book in exchange for your payment. So Amazon here is really a central service provider. Similar to banks, we deposit our money into banks, our cash. The bank keeps track of our balance, and the bank lets us then send our money to other individuals by giving them instructions. Now, whether that transaction is initiated by yourself going to the bank, or whether the instruction comes from you using the application, we're still trusting the bank to undertake that transaction, and we're still trusting the bank with our money. If we look at how payments are made nowadays, so let's say that Bob here would like to send 10,000 euros to Alice. And Bob goes to the bank and he says, and he asks the bank, he tells them that he would like to send 10,000 euros to Alice from his account. And the bank asks, what is it for? And rightly so, the bank needs to know why, what transactions are for above a certain limit, because the banks need to make sure that there are no transactions pertaining to money laundering and funding of terrorism. And Bob says, I would rather not say, it's private. Perhaps Bob lives in a small place like Malta, and Bob might even know the teller, and he doesn't want to disclose the products that he's purchasing. Perhaps he's purchasing some childish hobby items from Alice, some perhaps childish comics, and he doesn't want to reveal this to the teller. And therefore the bank says, I'm sorry, but we cannot undertake that transaction for you. And Bob says, but it's my money. Why can I not send my money to Alice? And this is really where the idea of cryptocurrencies emerged from allowing for people like Bob to be able to transfer his money directly to Alice without having to go through an intermediary. Now, we already have mechanisms like this. We have cash, but we want to have a digital form of cash where there are no central service authorities, central service providers that need to approve or who can reject such transactions. And this was the idea behind Bitcoin. The idea to enable for a digital cash system that allowed for peer-to-peer transactions, so allowing for any individual to send transactions to any other individual without requiring any intermediary. And if we think about how to implement, how to create such a system, let's first look at how would we create a banking system. Well, this is quite easy to do. You create a computer system, a database that stores all of the accounts all of the balances of each individual. And whenever a transaction takes place, that transaction is added to the system and the balances are updated. It gets slightly more complicated when you have a number of banks or financial institutions speaking to each other, but really it's the same system, and between banks, they just end up sending transactions to each other and the associated money for those transactions. But let's look at an even simpler way of keeping track of accounts at a balance. Let's say that we went to a non-digital system where we just had this book, and this book kept track of every single transaction. It's a ledger, and every single account. Now, we need a person, let's say myself, I work at the bank, and I will make sure that the transactions that are written into this book abide by a certain number of rules. And when an individual wants to transfer their money or pay someone, this involves a transaction being added to the ledger, which says that the sender, person A, is sending an amount of money, X, to the recipient, person B. And I add in this transaction into the ledger, and I update their balances. Now, I need to make sure that I will only write an entry that sends money from person A's account when it is person A that is telling me. So when Bob tells me that he wants to send his money from his account, I make sure that it's really Bob. If someone else tells me, let's say if Jack tells me that he wants to send money from Bob's account, I won't allow that to happen. So I won't let that transaction take place. So only the owner of their assets can send or transfer their assets. Now, some other rules that I need to make sure take place are that no one can send or transfer more money than they have. And once a transaction is written into this ledger, it can never be removed and it can never be changed, because otherwise we could transfer money and then take that money back. Now, importantly, there can only be one ledger, one book. If there's multiple of them, then it'll be hard for us to keep track of the balances of all the different individuals. And we can also have two different transactions which cause a conflict being written in the different books. And no one can manipulate or change this book except for the bank, except for me, the person who's making sure that these rules are being kept. Now, if we want to implement a digital system, it will do exactly the same thing. It upholds these rules, but the governing policy is being implemented by a computer rather than from a human overlooking the process. However, the problem with these systems, both in the case of the manual ledger as well as the digitized system, is that the owner, the central service provider, can manipulate the book, right? So in the case of the digital computer, the organization, the bank who has that computer under their control can manipulate it in any means that they deem fit. And also, this manual ledger, if I am controlling it, I could decide to make some changes or manipulate it. I could tear out a sheet and decide to copy a number of transactions except one. So in both these cases, there's a single central service provider that we need to trust. Now, when it comes to decentralized ledgers, when it comes to creating a system where there's no single central service provider that needs to be trusted, then it means that there's no single place where this ledger will exist and no single person who has control of it. So we need to replicate the ledger of transactions everywhere in our network. So every person who wants to interact with this system will need to have a computer that has a copy of this ledger. So different to the other implementation where there can only be one book, here to get rid of that central point of trust, we make sure that everyone has a copy of the ledger. But we still need to uphold these properties. We still need to make sure that no one can change or remove transactions. And before I mention that if you have more than one book, this is a problem. How can we make sure that these properties are upheld when everyone has a copy? And we'll come to the solution of how this is possible. But the nice thing about this is that there's no single owner of the ledger. Now what we need to make sure is that every single copy remains identical to the other and cannot be manipulated. And this is actually something that's not easy to do. So it's a system where there's no central authority, where every node needs to have a copy of the ledger, including all accounts, all transactions and balances that ever took place. And whenever a transaction takes place, it needs to be sent to all the other computers. And we need to update the balances on all the other computers. And how can we make sure that this happens? Well, this is a problem that we've only recently solved. And the solution to this problem is the blockchain. So the blockchain allows for us to have different copies of data of the ledger stored at different people on different computers around the world without there being a single central point of trust, without there being one single computer or service provider that is more important to the others to make sure that the system works. This is what the blockchain provides. Every single computer will have an identical copy of the ledger. And it will make sure that only the owner of their assets or money or crypto can transfer their assets. It will make sure that transactions can never be removed from it, but they can only be appended to the ledger. And once that transaction has been appended, that transaction will never be removed. And this is what we mean by immutable, if you've heard the keyword. It means that the transaction, once accepted, can never change. But really, if you think about it, even though this is the system that is being provided, where there's no single point of trust, the way that we as users will interact with the system will be very similar to the way we interact with current systems. We'll be using a web page and we'll want to transfer money to another individual. Now, what it's doing is removing the single point of trust. In this particular example, let's say the bank. And instead, we'll just be transferring our money directly using the software. So now we're trusting the software to do its job rather than the bank to do its job. But the nice thing about this solution of decentralization is that if the software is written correctly, then no one can manipulate or cheat in the system.
Okay, so are there any questions at this point? Perhaps something's not clear. So everything should be clear at this point. Then let's see if there are any hands raised.
We've got one question. Oh, just a comment. Maybe we'll just give people a moment to maybe capture their thoughts.
Okay, so if there are questions, you can ask them at any point in time, and then we'll just get to them as soon as possible. So I think we can continue with the slide deck.
Now, Bitcoin was the first proposed system like this. And in Bitcoin, they used a blockchain. They proposed in Bitcoin this new mechanism, the blockchain. So Bitcoin makes use of a blockchain. And Bitcoin is really nothing more than a ledger of transactions, just like the ledger of transactions that we saw used in a bank. And we can see that Bitcoin really is a ledger which guarantees that only the owner of their money or resources can transfer their resources. Only one transaction can be performed at a time. Now, this isn't entirely true. So really transactions are batched together in blocks, but for simplicity's sake, just think that one transaction happens at a time. And old transfers cannot be manipulated or lost. So once a transaction is added, it can't be removed. So let's say that we have these 3 wallets, these 3 accounts, and I own 10 Bitcoin and Gordon owns 3 Bitcoin and Alice owns 6 Bitcoin. Now, if I want to transfer 3 Bitcoin to Gordon, from Joshua's account to Gordon's account, this will involve decreasing 3 Bitcoin from my balance and increasing 3 Bitcoin to Gordon's balance and adding this transaction to the ledger. Next, if I want to send 1 Bitcoin to Alice, the same thing happens again. We add a transaction to the ledger, which will result in 1 Bitcoin leaving my account and entering Alice's account. And similarly, if Alice transfers 3 Bitcoin to Gordon, we add another transaction in the ledger. So from the user point of view, ignoring the fact that it's on a blockchain, this is what it's providing. Now, if you want to start using Bitcoin or really any other blockchain, how can you go about doing it? Well, there's a number of different types of software out there, but the most traditional way of doing it would be to install a Bitcoin or whatever system you're using, installing a full node. And this full node is typically a piece of freely available software that you can download from the internet. And very often the software is also open source, which means the code written to create the system is actually public as well, so you can inspect it. And this full node, after you install it on your computer, it will connect to the other computers that are running Bitcoin, and it will ask them to send it all the transactions, all the entries in the ledgers that have ever took place. And it will receive all these transactions, and then once it has the full set of transactions, it will be able to interact with the network and send transactions, new Bitcoin transfers, transactions into the network. And when you're using this software using a full node, you have full guarantee that if someone transfers funds to your account and you see that on your full node they've been received, you have a guarantee that those funds have actually been received in your account. And there's no single point of trust that could have stopped that transaction. Now, for this to be completely confirmed that the transfer took place, you need to wait a while, but I won't go into the mechanics of how and when, how long you have to wait. But in the case of Bitcoin, it's typically 1 hour. In other types of systems, it can even be down to a minute or a few minutes to have the guarantee that that transfer has taken place. Now, this is one way of using a Bitcoin full node. This is one way of interacting with Bitcoin, where you have full guarantees because you're running the full software yourself. You can also run what we call light clients that don't have the full history of transactions, but it has enough information inside of it to be able to build the guarantee that when a transaction takes place and you receive some funds, that transaction is actually valid. So those are the main ways that you can interact with such systems. And then we can also interact with blockchain-based systems and let's say Bitcoin by not having the software installed ourselves, but using a web browser on your computer or using a web browser on your phone, going to an internet page and speaking to a server, someone who's providing an interface to the blockchain or to the Bitcoin network. So this is very often what exchanges provide, who exchange from normal currency, from fiat currency into cryptocurrency. However, it's very important to note that when you're using this service provider, you're back to a point of trust. You're now trusting this service provider to be undertaking transactions for you. Now, how do you know if they're claiming that you have so much Bitcoin in your account? How do you know that it's really there? So for full guarantees, you should have the software running yourself. If you want to use exchanges, the guarantees are not as high because then you need to start trusting the exchange.
Okay, so I'll get to some questions. So the blockchain is made up of many computers and what we call nodes working together. Now, couldn't we just use the cloud rather than use all of our computers working together? Well, really, if you think about it, the cloud isn't of itself a lot of computers working together. So yes, you could use a blockchain that is running in a cloud. And in fact, Google and IBM and various providers are offering blockchain from a cloud. But just like I mentioned here, when you're using an external service provider who might be running a blockchain system, if you don't have direct access to that blockchain, then you're now trusting the service provider to make sure that they are really using a blockchain. So this is the main trade-off. Either we have full guarantees of what is going on because we have full visibility inside the software on your computer, or we delegate our trust. Now, this might raise some questions in regards to if you're not a developer and you have the software running, do you really know if it's doing what it should be doing? Well, yeah, you don't because you're not a software developer, but you could always learn to code. You could always learn to understand what is going on in the machine. You could always ask a friend. So this is why blockchain systems are seen to be more democratic, because it gives complete transparency and it allows for anyone to take part of the system, even if they don't have the knowledge. They can always learn to get it. So what is the difference between blockchain and Forex trading? So blockchain is the mechanism that allows for services to be executed and to be offered using any number of computers where there's no single central authority, there's no single owner. Now, Forex systems, exchanges are providing for a service of exchange of one currency to another currency. And Forex exchanges are not necessarily using this type of decentralized network. So a Forex exchange might just be a single computer that you connect to, and you ask the Forex exchange to send you, let's say, US dollars in exchange for euros, or it could be you ask for Bitcoin in exchange for euros. However, you're trusting the Forex exchange here, who is the service provider. So that, and the main difference is that blockchain is a technology that enables for us to remove these central service providers. And one big question we need to ask is, which service providers, which central authorities do we want to remove? And I think this is what Alex was hinting at. In 2017 and 18, there was a huge hype to use blockchain for everything. And I think that was actually the downfall of blockchain. We should only be using blockchain where it actually can provide a useful service. So I think what's key here is to understand what blockchain provides and when should we actually use blockchain. Now, coming to the question of, are there any other applications that blockchain can be used for? We're coming to them very soon. Okay.
Now, I've said a number of times that every computer, or what we call node in the system, in the blockchain, will download a list of all the transactions, accounts, and balances and data that ever took place. Now, if that's the case, does it mean that everyone can see how much Bitcoin I own? And the answer is kind of yes, and it's kind of no. It's yes, because like I said, all accounts, all balances, all transactions are downloaded and available for everyone to see. It's kind of no, because Bitcoin only lists your account addresses, which is a unique number, a unique long number associated with your transactions. And there's no name associated with this account. It's what we call pseudo-anonymous, in that there is an amount of anonymity. However, it's not completely anonymous. So the first time that you transfer some funds to another individual, suddenly they can see the address where they were sent from, and then they can start tracking other transactions associated with that. So the key point for public blockchain systems, and I'll come to what a public blockchain is is that the data is available for everyone to see and for everyone to download. And Bitcoin is what we call a public blockchain, which means it's open to anyone to use. Anyone can download the software and be part of the system and look at the data. And if that's the case, that anyone can look at the data, what does that mean about confidential information? Well, if you have confidential information, you don't want that information to be stored or visible to everyone. So you definitely shouldn't be storing that on a public blockchain. But this is where permission and private blockchains come in. So if you have an amount of data or processes that you want to use amongst a number of different people or entities or computers, and you don't want anyone else to be able to see it, the rest of the prying eyes of the world to get access to it, you can create a private or permission blockchain which only allows the entities, people that you want to have access to that system to gain access. And anyone else that tries will not be given access. So in such a system, we can build trust between all of these different parties without having a single central service provider or point of trust. So just to disambiguate some terminology that you may have heard, Bitcoin is just one instance of a cryptocurrency. There are many other types. There are many other cryptocurrencies out there. Cryptocurrency is just one application of blockchain. We can use a blockchain for many other things than just keeping track of cryptocurrency, of ownership of digital assets. So it's similar to how we can use a computer database to keep track of bank accounts. We can also use a computer database for national ID registries. We can use it for creating a system, for creating an online purchasing system, an online shop. So just like a database, a blockchain is just the technology, and we can use that technology to create many things. And cryptocurrency is just one of the things we can create. And blockchain is just one type of a DLT. It's just one way for us to implement a distributed ledger. We can implement a distributed ledger using other types of techniques. And distributed ledger technology is the umbrella term for all of these types of techniques. And there are other types out there, such as directed acyclic graphs using IOTA and hash graphs and all sorts of other proposals. Each distributed ledger, each DLT, could be either public, which means it can be open and accessible to all, or it can be private or permissioned, which means that only a group of entities that agree to work together will have access to the particular DLT. And like we said before, Bitcoin is a public blockchain. So just to summarize what blockchain actually provides to us and what it is, a blockchain is a way of keeping a ledger distributed amongst all the partners, amongst all the participants, which manages to keep track of ownership of digital resources or money. And it ensures that only one individual can own their resources, although there are other ways to have shared resources. And it guarantees that an individual cannot overspend the amount of cryptocurrency or money that they have. And they also can't double spend. And what double spend means is if you have one last euro, let's say, in your account, you can't be able to both spend that euro for a burger at one shop and spend that same euro for a book at another shop at the very same time. So that is what we call double spending, and such a system guarantees that this cannot occur. So the ledger guarantees that identical copies can be stored on all the different participants, on all the different computers, nodes. And even though we have identical copies, the history cannot be modified or manipulated by any of the individuals. It needs to ensure that all of these rules are kept. And it can achieve this without having a single owner, without having a single service provider or a single point of trust that needs to make sure the system operates. And so far, we've really just been talking about cryptocurrencies. We've been talking about money, a way of keeping track of ownership of these digital assets. And really, when I say money here, I use it quite loosely because the definition of money, as according to law, might be slightly different, but we know what money means to us, right? So it's not just about money, though. It's not just about cryptocurrencies. Really, it's about ownership. It's about ownership of assets, of digital assets. And these digital assets are stored in the ledger and can be transferred and passed around as required by the owners. So let's say that we have a national property register that keeps track of ownership of land, of property. Now, just how we could keep track of ownership of Bitcoin, we can also keep track of ownership of land. So let's say that we have these different accounts like before, and I own this particular place in Floriana, and I received this from Paul, so I just received it because this transaction was added to the ledger. And I decide that I'm going to sell my property to Gordon, so Gordon pays me cash or let's say crypto, whatever, and we add an entry into the ledger. Joshua sends his property to Gordon, and the property I'm sending is the Floriana one, and it gets transferred from my account to Gordon's. So really using this ledger, we can keep track of any ownership, of digital ownership of digital assets. There are obviously some questions that get raised. Does this digital asset over here, the fact that you own this in the system, does that really mean you own the property in real life? Well, we've created a system to do it. Now, whether the land registry or the law of the land of the particular jurisdiction honors the fact that this digital registry is the true representation of ownership of land, then sure, why not? But using blockchain, we can now have a system that keeps track of ownership of property without having to trust a central authority. So there were cases around the world in the past where property was taken away from people because a piece of paper in the authority got lost or manipulated. So using such a system, we could avoid these cases. Now consider this scenario. Consider that we have this concept of a Malta parking pass. And the idea behind this parking pass is that you can use it to park in special bays, parking bays. And you can also use it to use public transport, perhaps. And you can also, once you have these passes, you can buy, you can sell or trade them as you deem necessary. And let's say that in this system, the government wants to encourage people to use public transport more and to use their cars less often. So what they say is if you do not use a parking pass for a whole week, then you're rewarded with more parking passes. So the lesser you use it, the more parking passes you're rewarded with. You can park in reserved special parking bays by spending 5 parking passes. And you can trade and sell these parking passes as you deem fit. And let's say you can also use a taxi when you accumulate 10 parking passes. Now, don't worry about the actual numbers and whether the economy system defined here makes sense, but just appreciate the type of system we're trying to implement. And let's say that we're keeping track of these different balances. So I have 5 parking passes, Gordon has 1, and Alice has 10. And the Malta Parking Pass Authority is going to receive these parking passes when you use a special bay. So when you use a special bay, you'll be paying those parking passes to the authority. And let's say that Alice decides to use some parking passes to park in a special bay. Like before, we would add an entry into a ledger, a transaction entry, and the balances of parking passes would change. Now, there's a problem with this system. The system will work in a decentralized manner, which means that there's no single point of trust, there's no single central authority that can stop these transactions or manipulate transactions. So we're guaranteed that our ledger will work properly and transactions will be properly added and the balances will be properly updated. But there is an issue here that we're trying to decentralize the system. We're trying to get rid of points of trusts. We're trying to get rid of central authorities. And yet we have this Malta Parking Pass Authority who gets to decide when you are rewarded with parking passes. So how can you trust that the Malta Parking Pass Authority will really give you those 3 parking passes you're promised if you do not use your car for a week? How can you be sure that you will really be given that 1 parking pass every time you use the bus? So these are issues of trust that are currently, with the system that we have, we can't get around them. We have to trust this service provider. So this is where smart contracts come in. You might have already heard the term, and it would have been better if the smart contracts were not termed smart contracts. So the idea here was originally envisaged by Nick Szabo in the mid-90s. And Nick Szabo envisaged that we could someday have contracts in a digital format that can fulfill their parts of the contract digitally in an automated manner. And if one were to try to break the contract, then it would be very hard for them to do so. So these smart contracts would have to be very robust against vandalism, against naive vandalism, and against individuals trying to break the contract. And in 2013, Ethereum was launched. And the idea behind Ethereum, which is another type of blockchain like Bitcoin, so Bitcoin is a blockchain and Ethereum is another type of blockchain, but Ethereum proposed that we could use a blockchain not only for keeping track of transactions, but we could run programs on the blockchain, run computer software on the blockchain, which would allow anyone to write a smart contract. So Ethereum managed to implement this idea that was conceived around 20 years prior. And what smart contracts actually are programs, are software code that executes on the blockchain. They are applications, they are code, software that will execute and do exactly what they're written to do. And no one can manipulate it because it's written on the blockchain. And no one can stop it. And it will do exactly what it is written to do. But the term is not the best term because in the legal sense, contracts define obligations and consequences of breaking those obligations, whereas smart contracts will execute the code that is scripted within the smart contract. So there's no way for an individual to breach the smart contract because it does not allow for breaching. And a smart contract is actually the automated execution of obligations. Now, often in computer science, when we say smart, we refer to systems that are artificially intelligent, and smart contracts typically do not have an element of intelligence, or rather artificial intelligence, although they could. But let's look at an example now. So let's say here that there's this company, Greater Charleston Properties, and they're a real estate company. And in order to encourage sales, they decide that whenever you buy a property from them, they will donate 10% of the amount of the purchase amount to a charity of your choice. Now, if we wanted to go and create a system for Greater Charleston Properties to do this, we could use the typical systems that we know, where as the buyer, you sign a contract with the company and they sign the contract that they will actually make this donation. And if they don't, then you can hold them liable and sue them. Although it might be a bit difficult to track down whether or not they've actually undertaken the donation. Another solution could be to use a trusted party that we both trust. So let's say you could use a notary that you trust to hold the money, and Greater Charleston Properties could also trust the notary. And like that, you solve the issue that you're guaranteed that the notary will make the donation to the charity of your choice, and Greater Charleston Properties can trust that the notary will send them the funds upon agreement. Now, again, in these two cases, we still have a point of trust. In the first case, we're trusting the real estate company. In the second case, we're trusting the notary. What happens if the notary takes off with the money? What happens if the notary claims that they made the donation and they didn't? So a solution that we can now achieve is to use a smart contract. And what is a smart contract? Well, it's an account on a blockchain that has code associated with it that can store digital assets. So a smart contract can store its own cryptocurrency, and it can execute the code that's written in the smart contract. And it can execute this in a manner such that no one can tamper with that code. Once it's written on the blockchain, that code will do exactly what it's written to do. And it'll do all of this without any point of trust, without any single owner that can manipulate the system. So let's say we wanted to implement a smart contract for this donation agreement. It could look something like this. And over here, this is code-like, though it's written in English. And what we're saying is that this is a contract called 10%. And inside the contract, it's keeping track of the balance of cryptocurrency that belongs to the real estate company, the company balance. And it has two actions that it can take from external parties in the real world. One action is that you can buy a property, you can pay in an amount into the smart contract, and it allows for anyone to pay an amount of money into the smart contract, so anyone can buy a property, and that property will cost whatever amount of cryptocurrency you send into it. And it will undertake these instructions when this is done. It will immediately send 10% of the amount of cryptocurrency passed in for payment for the property to the charity of your choice if you're buying a property. And the remaining 90% is stored inside the smart contract, inside the company balance, which belongs to the real estate agency. That's it. That's all it does for that first action. A second action would then need to allow for the real estate company to withdraw their funds that are stored within the smart contract. So because these actions are available for anyone to use, we need to make sure that we specify who can use the action. So who can withdraw funds from the smart contract? Well, only this company should be able to draw. So you may have some code that enforces that only the company can withdraw funds from the smart contract, and it can only withdraw an amount that does not exceed the balance that has been passed in. So the 90% balance that has been passed in. And then the smart contract will reduce the company's balance by the amount they're requesting to withdraw, and it will send that amount to the account belonging to the real estate company. And all this is done without a point of trust. This contract is written on the blockchain. No one can manipulate these instructions. When someone buys a property, the real estate agency can have guarantees and see that this donation was sent to a charity of their choice. So the purchaser is not saving that 10%, it's really going to a charity. And the buyer has guaranteed that the real estate agency isn't going to pocket that 10%. And the real estate agency also has a guarantee that they're going to receive that 90%. So you can think about this type of system as also a vending machine. Sometimes this analogy is used where you have some logic, you have some mechanics operating inside the vending machine that you can't really see, but you can press the buttons to interact with it. And this vending machine inside will do exactly what it's meant to do. Now, it might not be the best analogy because sometimes vending machines break down, but you could have a button where you pass money in to buy the property. And over here, when you want to withdraw money, you have to prove that you are actually the company. So you can think about using a smart contract much like different buttons that are available on a vending machine or perhaps on a website.
Okay, so before we continue, we'll just wrap up in regards to why we should use, or rather when we should use blockchain, DLT, and smart contracts. And then we can move on to a few applications. Now, I cover a number of different applications to give you an idea of how it can be used to remove central authorities. And I could go into, let's say, land registries, transportation, voting, and education, or I could just jump straight into education. So could you please quickly, if you want me to jump straight to education, just write education in the chat. Or yeah, just write education in the chat. If you have no preference, okay, so if you have no preference, different use is all interesting. Okay, so far there's 2, 3 for education, education. Yeah, I think the difference between blockchain multi-party computation. Okay, so the difference between blockchain and multi-party computation is the question. Now, when you think about it, a blockchain is multi-party computation. It is multi-party computation where every single computer in the network is doing the same computation. Now, if we start thinking about using systems like zero-knowledge proofs. Now, zero-knowledge proofs are a way to prove that you've actually done something in the real world, but you don't disclose all the information to the blockchain. By using these mechanisms, we can implement more systems that rely on multi-party computation, but also allow for the decentralized networks that we're using. And if you're interested in that, I highly recommend that you look into Ethereum, Microsoft, and EY's baseline protocol, because that is exactly what they're proposing. So what I'll do is I will jump to education. However, we will make these slides available and the video available for anyone who wants to see that. Actually, before I do that, I do want to summarize why you need blockchain, because otherwise we lost the whole point of this video.
And over here, when you want to withdraw money, you have to prove that you are DLT and smart contracts. So back in 2017, there was a blockchain hype, and perhaps it's still going on till today, where everyone thought that they require blockchain for every system. But really, you should start with the main difference that blockchain provides. It allows for us to remove and instill trust in places. So do you have a system that does not have a single point of trust who all the different parties can trust? If there's no single party who is ideal to trust, then blockchain could provide a solution, because it will do exactly what it's written to do, and the blockchain will act as that trusted party. Do you have a system typically where your participants want to control and transfer resources? then blockchain is a good solution. Do you need to provide some guarantee to your participants that some logic, some code, some mechanics have been undertaken, for example, or will be undertaken? For example, how can you provide a guarantee to a client that he can take his money back after a particular deadline? Using a smart contract, you can implement that functionality, and the client can have the assurance that the smart contract will do exactly what it's written to do. Do you require decentralization? So is there a point of trust? Is there a service provider that you would like to remove from the equation? Blockchain is all about that. Is the application data intensive? Does it require a lot of data? Is there a lot of data being generated that needs to be stored? Blockchain and DLTs are typically terrible at storing lots of data. So you would not use a blockchain for such systems. You may use a hybrid system where you use the blockchain for guarantees and you use a centralized system for the data. And ultimately, if you come to the conclusion that blockchain is a good solution for your system, for what you're trying to do, you should ask the question, would it be fine if I were to just set up a computer, set up a server on, let's say, a service provider like Google and Amazon? If I were to set up a server there and just have it running the system, if that is an acceptable option, then blockchain is not needed. If you are fine with hosting and running your software and having a single owner of the system, then there's no need for blockchain.
Okay, so I'm just going to jump to education.
Final result is revealed at the end. And we can then use these in elections, even let's say national, or let's say, or in board motions. Consider this scenario. So you go to lectures, you study, and you sit for your exams. You graduate and you celebrate, and you land your first job. You climb the ladder of success, and war breaks out in your country. You need to leave your homeland, and you settle in a new homeland, and it finally becomes your home. And you go for a job interview, and you land the job. They're impressed with you. But they just want to make sure that you have the background, and they ask for your certificate, for your educational certificate. But you do not have it because it was lost in the war. And not only that, the certificate registry was destroyed in the war. So there's no way for you to prove that you are the best doctor, you are the best lawyer, the best professional in your area. There's no way for you to prove that you have that certificate. And this is actually based on a real world case. And this has happened in various places in the world. So wouldn't it be great if we could use a blockchain as a registry of certificates for educational certificates and diplomas that cannot be taken away from you just because the piece of paper went missing or the certificate registry was destroyed? So using a blockchain, we could have a permanent storage and a tamper-proof storage of the different certificates that are being issued by the different educational institutions, such as universities. So this is the issuer, the university, putting onto the blockchain the fact that you own, that you have been granted a particular certificate, that you've received that education. And then when you go to an employer, the employer will then verify that you are the owner of that certificate on the blockchain. And this is implementation BlockCerts, which was proposed by Learning Machine, and this has been launched in a number of places, including Malta.
Okay, so we'll move on to various applications of where we can see blockchain being used and perhaps even where we shouldn't be using it. Before I get to that, I'd just like to answer a few questions. So what is Ethereum 1559? Now, I won't go too much into the detail of this because it's quite technical, but the way that smart contracts are run on a blockchain, or at least on, let's say, Ethereum, is you need to pay some money to execute it. So every time you want to, let's say, store a educational certificate on the blockchain, you need to pay some crypto, some ether, to actually do that. Every time you want to verify, well, actually, if you're just verifying, you don't need to pay for it, but it's any time you want to upload or change something on the blockchain. Now, this payment that we're paying for execution, we call it gas. And the rate of which you pay for gas changes. So this Ethereum 1559 proposal is trying to get around the problems of gas prices changing a lot. So I'll just end that discussion over there. So another question was regarding, could we store medical certificates on the blockchain? Yes, we could store medical certificates, any type of certificate. The blockchain is brilliant for storing some information that needs to be verified at a later point in time. And the person who uploads it, let's say that as a university, we start uploading our educational certificates on blockchain. As the university, we have a unique identifier. And anyone around the world can look at that certificate on blockchain and verify that it was issued by the University of Malta. So I would say we can now open up the discussion to, or there's a few more questions coming in. So does blockchain make use of machine learning? No. So machine learning is a type of artificial intelligence. Whilst you could, in theory, write a smart contract or have code on the blockchain that uses machine learning, we typically don't see it, but there's nothing theoretically stopping someone from running a machine learning algorithm on a blockchain. Okay, so yeah, blockchain and GDPR. The two, they're terrible. They're not friends at all. So at one end of the spectrum, we have blockchain, which is saying data written on the blockchain is there forever. At the other end, we have GDPR saying, if it's personal data, you have the right to remove that personal data. There's no way you're going to do it with a blockchain. I'd like to see how they're going to get around this. I mean, my personal advice for anyone using blockchain is never put any personal information on a blockchain. The information that you disclose should be information that you're happy to, number one, be public, and number two, be public forever. And this actually causes problems because we might have data being uploaded onto the blockchain that we're not uploading ourselves. So let's say my friend uploads my home address, my contact details, and all sorts of other personal information. There's nothing I can do to get rid of that information. What can we do? We tell every single computer in the blockchain network to turn off. It's not going to happen. So actually, there's a recent opinion piece on this from Cointelegraph, who discuss various different concerns that we now need to look into, because we're going to live in a world where the past cannot be forgotten. And yeah, we don't know where it's going. So my personal advice is, if it's personal information, do not put it on a blockchain. So I'm not sure if there are any other questions, or Alex, do you want to?
I think it's something which, it's something I keep on thinking about. And even because I was very much mired into running a big blockchain project here, which is the whole issue of, I mean, we keep on mentioning trust and trustless technologies, and then governance, right? And governance normally is synonymous with government. So, you know, which government would ever really be comfortable with distributed ledger technology or distribution, or, you know, trust in the machine, because we're technically supposed to have trust in the governments that we elect. Okay, so it's a bit of a philosophical question, but there's a deep education thing below this, trust me.
Yeah, definitely. Because if we're thinking about not just governance at the governmental level, but let's say governance of a university. And currently we talked about putting educational certificates on a blockchain. But when we talk about honoring or looking at the certificate and saying, that came from the University of Malta, we trust Joshua's program, so we know it's good. Okay, that's great, but University of Malta, a central point of trust, is putting it on the blockchain. Now, there are initiatives out there to remove the university as that point of trust, where you can start building different credentials from all sorts of different places. And then we have to start questioning, as a world, as let's say an employer, are we happy with those governance structures? Or do we want to see the governance structures that we traditionally see in a university or any other educational institution? So I personally see that blockchain is really raising a lot of philosophical questions that honestly, I don't have the answers to, and I would like to see how this plays out. But we need to now, I think, start considering which points of trust, which service providers do we want to remove? And which ones are we happy with? The ones that we're happy with, maybe we shouldn't even be discussing removing them. But yeah, this is a discussion that can go on forever.
I mean, I'm aware that there are some people, if they're still hanging on in there, who are deeply enmeshed in some of these issues. Okay, I don't know if Taylor Kendall is really still out there. I'm aware of people like Luis, my friend, who is involved in something called the European Blockchain Partnership. I don't know if you guys know about this, but we may think that the blockchain is some sort of, you know, esoteric technology. The EU is investing millions in rolling out this technology for the public good. Diplomas, which is the name that in their wisdom the EU gave to credentials, is one of the first 4 pilot cases. And both Luis and I have been advising the Commission on this. One of the things we need to bear in mind, and which dovetails it to what Joshua is saying, is this: the problem of governance goes back to the institution. Okay, but the other thing is, when you come to credentials, it's all about who owns the credential. And this is again a moot point. In Malta, we decided early on that the credential belongs to the recipient. That if we really believe in the self-sovereignty of the recipient, that empowering learners, and especially if you believe in the portability of credentials, moving from one country to the other and these being recognized. Self-sovereignty means self-sovereignty of the citizen. And that's why people like Luis, who are experts from a technology point of view, but the sort of job we're trying to do is try and get the technical people who get excited about the whole concept of self-sovereignty and smart contracts and what it can do. And on the other side, you have institutions who it's only until recently, i.e. COVID, that many of them have had to mobilize and go online. My hope is that, and this is why we want to do these blockchain webinars in layers in a way, is that because the next one will really start to dive in onto credentials and self-sovereignty and empowerment. I mean, my hope is that because of the crisis that we're all going through as educators, as learners, there might be some interesting things which start to happen now, which seem to be science fiction, I guess, in the past. But I don't know how our colleagues think about this. Okay, just simply something I'm floating.
Yep, and as well, blockchain is changing education not only because of what it provides as a mechanism, but also because of the education that's required for now people who are able to work with decentralized systems. And if we look at the blockchain technology, it's really impacting not only technologists who are going to work with the technology, but it has legal ramifications. How can we stop a node from continuing to distribute my personal information? We can't. What are the legal implications there? When it comes to cryptocurrency, how are we going to regulate this space? And what we really noticed in Malta is that the technologists, the legal, the business, and the finance people, we can no longer look at this technology or this domain from our single point of view. We have to have a multidisciplinary approach to understanding this technology. And I think this is going to be key now in areas where blockchain starts to really be pushed. And again, it's not about the technology. This is about a paradigm shift of removing those central authorities. And that is the main question that we need to ask. What authorities are we happy with? Which ones do we want to remove?
There's one final point I will make, which is there's another big word which is mooted around, which seems like a technical word. It's called interoperability. But really it means mutual recognition, that you can have a system which is in one country, which is recognized in another country. Now, remember that in this part, at least in Europe, in Africa may be different, okay? But in Europe, every single nation state has sovereignty of their own education system. Okay, so it's up to every single, and with the rise of populism and the strange times that we're living in, okay, the idea of countries collaborating seems to be more challenging than ever. And I would hazard the guess that the blockchain can really give us this opportunity. For instance, for a credential which originates with somebody who starts to study in Spain and then decides to move to Portugal or goes to Poland, but it needs people in governance positions and policymakers to get together. So this whole idea of even notarizing public records and putting them on the blockchain. Remember, you don't have to be a rocket scientist to realize that, as somebody noted, you can go from education records to public health records to registering cars, deaths, and birth certificates, you name it. In India, I don't know how many millions of people don't exist, for instance. So think in terms of even the right to exist and citizenship and things like that. And also the example that Joshua was using in terms of people, refugees, people who actually, got on a boat, left Syria, and somehow ended up, at least even in this part of the world. In our case, we wanted to use the blockchain that once people arrived in this tiny island without any credentials and got tested again and got assessed again, when that certificate was issued by whatever authority it might have been, that certificate is notarized on the blockchain so that nobody can take it away from them. And there's some very powerful arguments behind this. Okay, there's some more questions here.
Yeah. So looking at Erasmus diplomas, mutual recognition with Latin America using blockchain, I think that would be excellent if that could be achieved. So, I mean, right now we could sit down, we could create a computer system that tracks certificates. We can do that. I think one of the big questions is how do we convince all the various players to move on to such a system? So would the central authority in education provision in a particular jurisdiction, would they trust to use a blockchain over their own system? So I think we even need to educate the various people in various positions of governance to show them that blockchain has some potential here. And that might not be easy because a lot of these people in these positions of power, they might want to keep that power. So I think, I'm not sure how to go about this. Sometimes the best way is to show them a test case that doesn't necessarily remove any power that they might have, and then slowly get the people to want such transparency.
Joshua, I wanted to pose a question as well. And I think in recognition of some of my invited partners from Namibia, from Mauritius, of course, Malta, Fiji, small states. And of course, in the space of the Commonwealth, there's a lot of them. Malta, of course, there's 30 plus. I was wanting to know if you can maybe juxtapose, how this could be moved forward in a small state, and maybe offer some insights as to what's happening in Malta and maybe what you might see in the next 5 years, and perhaps offer some inputs to those individuals as well. Again, representing or being cognizant of the small states, and obviously, arguably smaller bureaucracy, smaller populations, that's for sure. But I'll stop there, and if we can offer some remarks on that.
Yeah, so the nice thing about places like Malta and small states is that the people involved in the space won't be more than a handful of people and a few calls away. So it's easy to pass regulation, it's easy to undertake a test bed. Now, when it comes to setting up a system like this, you really have to find a unique selling point where the governance structure will see that that's a benefit to them. Now, if a particular government is suffering from perhaps reputational damage, blockchain is brilliant for them for transparency. So a government could set up their own blockchain system, allowing for the whole population to have access to see the data, but not change the data. So the government is sure that they won't have any hackers potentially manipulate the data, but the individuals then have full transparency. And I think that could be an interesting way to push such an agenda. However, at the same time, the unfortunate thing about the blockchain space is that in 2017, crypto, everything was being hyped and so many people got into the space. And this is the same thing that happened in the dot-com bubble. A lot of these companies are going to go bust. So I think the best thing for us to do is to focus on pushing in blockchain through education, educating the students, educating the various individuals in governance. How can blockchain change various services? In Malta, that is exactly what we're trying to do now. So we're trying to have real world use cases that impact the individuals. Now, the educational certificate is brilliant. Mostly everyone goes to school here. When it comes to other applications like cryptocurrency, I think we need to stay a bit away from them. The problem of cryptocurrency is their price is very volatile. And until I can go out today and buy a burger and for the same amount, buy my burger tomorrow, we won't be using cryptocurrencies. It needs to be easy to access. So there's a few challenges, and I think education is the right one, is the right path to go down. So in Malta, we're going to implement a few use cases, and we hope that these use cases will really push the island forward in terms of blockchain. I'm not sure if, Alex, you have some insight into some other...
I don't know if it's helpful. I mean, we can also, once we share the recordings of these things, we can also put some literature that you could tap into. I mean, there's a report which, you know, I was involved in 2017 for the commission, which became a standard called Blockchain Education. Recently, there's been a publication from the Department of Education in the US. And it literally very much dovetails with the kind of opportunities that we saw in 2017, which tells you something. Maybe the world hasn't moved on. Education has never been very sexy, okay, when it comes to blockchain. But education is becoming really interesting because of the pandemic. Let's not ignore that. We're involved in the Horizon 2020 project, the center at the moment. And a lot of the conversation is, yes, there are emerging technologies on the way, but what has happened is fundamental thing called education. Is it going to remain the same? Is blended learning here forever? How are we going to operate? Is an institution just bricks and mortar? How can human beings behave online? And if you try and then start looking at things like the blockchain, are they useful or not? I think these kind of arguments are coming back to the fore. So I think in the same way that Joshua said, you know, after the dot-com bubble burst, and I'm old enough to remember it in 2000, and everybody scampered and went back to consulting. It was at that time that a lot of the stuff that we now call social media started being hatched, okay? Because at the time we're very much in Web 1.0. My feeling is that this is the time when you're gonna start seeing some real deep innovation, but it's very quiet. And I would suggest that those of us who happen to be in the education sector as educators, as, I don't know, organizers, facilitators, we need to look into this. The second thing is this thing about small states, which Kirk mentioned. Yes. Small states have an appetite for experimentation. So in our case, literally when we're going through the first pilots in Malta, the government of the Bahamas sent its entire, like a couple of permanent secretaries landed here. And we went through 2 workshops with us and went away and did their own thing. And they started putting on, by the way, public health records and other things and got more advanced. But the serial innovations, sometimes you got to look at what cities are doing or lone universities are doing or lone research centers. The trouble is when you get to this governance layer here, and in my part of the world, it's called the EC or the European Union. How do you get something to happen here? And I would stick my head out and say, you need to operate with a carrot and stick. You can build it, but they're not necessarily going to come. So maybe the one way around what's going to happen in Europe is by telling people, you know what, next time you want to go for your Erasmus Plus funding, and you need to go for Erasmus, you need to sign up to this system here called the blockchain, that the next time your education institution issues blockchain, it's got to use, for example, the EPSI standard, which is being rolled out at the moment. Okay, that might be the way around it, but I may be surprised.
Yeah, so I'd also like to mention that perhaps as small states, we could get together and develop educational initiatives, because if it's education that's going to drive this, we can, as a small state, really come up with a first-class education, I think, in this particular space, because we can be nimble. When it comes, Benjamin mentioned stable coins. So stable coins is a cryptocurrency that is tied to a particular currency. So you might have a particular company and they say, for every coin you have, we back it by a US dollar, and it always stays at the same price. But the big question you have to ask these types of stable coins is, do I trust the company who is making that promise? What happens if that company goes bust? Then you don't get your stable coins. So then moving forward, we're now having national jurisdictions. We're having China, Europe, the European Central Bank, looking into digital currencies backed by the jurisdiction. And I think really that's where we can reach mass adoption. When our jurisdiction saying, here, this is our national cryptocurrency, and suddenly we can go and create all types of different applications out there. So I have another question here. What happens if you forget your username and password? There's no one to speak to, right? Yeah. That's it. It's locked. It's gone. So many people have lost their key to their account, and they can see inside. They can see all their cryptocurrency, but they can't get it out. And that must be very frustrating. So there are different types of initiatives out there to get around this by giving custody. So you might trust a particular company to have custody of your keys, and you trust that they're going to take care of it. Now, that's one way to make sure you don't lose your keys, but now you're trusting the company. So the main question is all about trust. Yeah, cold wallets are a way too. So you could store it on a piece of paper, but what happens if you lose that paper? You're just not going to get access to it. So it always boils down to the same thing. When we're decentralizing a system, that central point of trust is removed. And there's no one you can contact if you lose that information, no matter what you're using. If it's a hardware wallet, a cold wallet. And these are the questions we need to ask. Which central points of trust are we happy with? Which ones do we want to remove?
I'm going to interject now, Joshua. Thanks for that. Obviously, there's a lot of stimulating questions and conversations to be had. But I'm going to just share my screen as a wrap up here. I was going to offer the space to for people to pose more questions, but time's not on our side, and I want to be respectful of our panelist and our facilitator, and of course all of you to get on with our days. So on that note, I just wanted to share a few final points. Joshua, Alex, thumbs up if you see my PowerPoint there. Yeah, okay. So just in the coming days, I wanted to show the recording will be posted on 3 different YouTube channels. The first is COLE, then there'll be our Commonwealth of Learning, where I'm representing. The next would be the Commonwealth Center for Connected Learning, which is our facilitator, Alex Grech, which he is representing. And then, of course, the third is Joshua's YouTube channel, the Digital Learning Technologies space, or Ledger, excuse me. The emails are there, so I invite you to contact us. I'll copy and paste those into the chat room as I move towards the next slide, and invite you to follow up with us. On that note, so on the right, of course, is the flyer that I had circulated around today's webinar. So again, thank you for all of the participants. We peaked at 41 out of 61 registrants, which I think is quite high, over 60%. I wanted to draw your attention to the second flyer on the left in the green, and that is going to be the next webinar coming up in just over a week's time on July 7th. And this will take that conversation, which Joshua is well placed in front of us, around credentials. And we'll talk about that in a context of, well, a bit more deeper, because we have this foundation that Joshua's illuminated and articulated very well. We can continue to build on that in the context of credentials. And of course, as this heading says, digital credentials in the pursuit of self-sovereignty, that notion that we just touched on a moment ago about ownership over your credentials. And of course, the perils of that when you forget your password, right? As a quick digression, you can Google, maybe Joshua, Alex know it better than me, but that individual who had millions in Bitcoin and couldn't find his password, and it was just there in the ether, if you will, unaccessible. So in any event, I hope that doesn't discourage you. I don't want to end on a sour note, but no, in all honesty, I think this is a really great discussion. I think there's a lot of opportunity to further this discussion. Of course, I would ideally like to have probed Joshua to invert that question around small states to our large states, and certainly want to give recognition to India and South Africa, which I know are on the call, and I'm sure maybe some other large countries as well. So just moving forward, I just want to again thank you for your participation, and special thanks to our panelist, Dr. Joshua Ellul from the University of Malta, and my facilitator and colleague, Dr. Alex Grech, for the added inputs, given he is also quite experienced and well-versed in the blockchain and education space. So there it is. July 7th is the next webinar. July 23rd will be the third of the series. We'll also be promoting another webinar July 16th around gamification. So again, stay tuned to my profile on LinkedIn or Alex's profile on LinkedIn. And we'll be obviously following up. We have all your emails as well to keep you in touch. So on that note, again, I'll give the final word to Joshua and then to Alex, and then I think we'll sign off.
Excellent. So thanks, everyone. If I didn't manage to get to any questions, feel free to send me an email or contact me on LinkedIn or anywhere. But thanks, everyone, for attending.
Okay, I mean, just to end up, I'm going to try and coax Joshua into our next webinar if he's around, because that will start to link between what happened today and where Natalie will take us. I would also ask you to look at the chat box as well. I can see that Luis there is talking about EPSI. I mean, Luis is the main, he's one of the conveners for the EPSI project in this part of the world, and he's a fountain of information if you ever want to reach out to him. And I just thank you for joining us. I mean, this is a bit of an experiment. I think what we're trying to do is activate our global networks. There are many people that we know who can help us, all of us, go through the spirit of co-learning. And that's what we're all trying to do now. And thank you, Kirk, for organizing all of this. I'm very grateful.
Thanks, everyone.
Okay, so I'll just leave the chat room up for a moment. There's our email addresses and our respective YouTube channels. Otherwise, I'll sign off maybe in another 30 seconds. And we'll leave it at that. So again, thank you all. Note that July 7th is the next webinar, and I will be posting that or sharing that by email to all of you. And you can, again, check out our LinkedIn profiles by just searching our names.